So in this video we're going to give you two of the special case examples, or the two special case examples for ray diagrams for lenses. First of all, with the object sitting right at the focal point. So we can always draw a parallel ray, and that will always go reflecting through the focal point. And now we've got our ray that will go straight through the center. Now, although I've drawn this a little bit oddly, what we'll find is that these two rays are parallel and they will never meet. Even if you go dot 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 backwards, they are parallel. So parallel rays, as we saw from the concave mirror, parallel rays don't meet, and therefore, and they don't even appear to come from a point, therefore there is no image. So that's our first special case example. Okay, our second special case example, a wee bit more involved, and same thing, this is the object inside F though, and the same thing, we have our parallel light ray that will refract through the focal point, and we can draw our ray coming through the optical center. Now it's not a bad drawing in this time, you can see that the rays are spreading, and by now you should know that an observer who's standing on this side of the lens and looking on, they'll see the rays as though they come from a point somewhere back here. Okay, and that's where our image is, where the rays appear to come from, and you can clearly see that it's enlarged, that it's upright, and that it is a virtual image. Because it's virtual, as we've seen, because we couldn't project this on a screen, and it's not made with real light rays, it's made with the dotted rays, because it's where they appear to come from. Now, this is our very useful situation, our most very useful lens. This is a magnifying glass. Very, very cool. This is our magnifying glass lens. And you can use this to make objects that are inside the focal point appear larger than they really are, so you can get a close-up look of what they are. So next time you have a chance to look at a magnifying glass, you should do so, and you can check that out. Now, the last thing I want to do is to draw ray diagrams for all situations, all on one axis, so you can see the progression of them. So here's our lens, here's our focal length, here's our twice the focal length, and as I said, this is an estimation because I'm drawing on the iPad. It's a little bit tricky to get it perfect, but if you are doing this for real, I suggest measuring it out and getting it very perfect, geometrically accurate. So we're going to do all five with our object in 5 different locations: outside 2F, at 2F, between F and 2F, at F, and inside F. Okay, so as we said, we've got the 1, 2, 3, 4, 5 situations. Now, same thing that we saw before, we can draw one parallel light ray through the top of all of them that's going to refract through the focal point. Okay, so that's our nice easy one. Now I'm going to start using different colours to show the rest of it. Okay, so they're all going to pass through the center, and you'll be able to see that it acts kind of like a pivot point. The closer you get, the more it pivots. And so here's our first light ray that we drew in the previous video. 1, so you can see that's where the image is. And our second, I'm just going to progress through colours, hopefully these colours are visible to you. Our second, through the center. Okay, and I've drawn this absolutely terribly because this is at 2F, and it should, let's see if I drew my line correctly. Yeah, if I drew my line correctly, it would be at 2F. Okay, and it would be the same size. They're all inverted, they're all real images you can project on a screen, but our second image here is the same size. Magnification is 1, so it's gone up. It was less than 1. Now it's gone up to 1, and you should be able to see that this third one should give us, yeah, they would cross over somewhere way down here, and that would give us our third image. And exactly the same before, you can project it on screen. It's a real image. It's enlarged and it's inverted. And it's just so much larger. And this makes sense because light rays coming closer to the focal point will go to infinity, making it larger. So there's this progression of increasing in size. Our second one, when we're at the focal length, this is the easy one. Remember, it's parallel to our ray coming through. I haven't drawn it perfectly because you can see I didn't go through the center. But if you dotted it back in both cases, they wouldn't meet either. And then last of all, when it's inside the focal point, and you can see that it's clearly spreading out, and which would mean our image is on this side. So it's really cool to see how that, I'm going to draw this slightly larger, how that light ray starts from 1 and then progresses down and pivots. And you can see that that's as it's going closer from there. And so our image is getting larger, and then it disappears, and then it goes back onto the other side, and it acts like a magnifying glass. I can't say for certain at this point whether it would be larger than our other one, but you can investigate that yourself if you like. So, worthwhile experience to draw all of these yourself. I can't say enough how important it is to practice your ray diagrams and to get a very clear idea in your mind of what to expect with each of them.